Okay, so for this question, we need to find the extrema, and so we will have to take the first derivative. So we'll bring down the 4, subtract 1, and so on. Now, once you are at this point, then you need to solve this equation. And the first thing that I would notice is that you have a cubic polynomial. So the important thing to notice is that it is a polynomial. And when you have a polynomial that is degree 2 or higher, one method that we usually use is we try to factor. So when we factor, the first question we need to ask ourselves, is there a GCF? So when you look at these two terms, you see that there is an 8 that is common to both terms, and the GCF is always the smallest exponent. So you have x to the first power. So again, keep in mind, you'll divide this by 8x, and that will give us x squared, x squared, and then you'll divide this by 8x, and that will give us -3. Now, we need to put our GCF out in front, and this will be our factored form of g prime. Now, once it is factored, we then set each of the factors equal to 0 as a method to find the critical numbers. So we'll take 8x and set that equal to 0, and then x squared minus 3 and set that equal to 0. Over here, we divide by 8, and we get x is equal to 0. Now, for the second equation, we notice that we can't really factor this in terms of like a perfect square, but because it is just x squared and a number, what we can do is we can use the square root method. So what we do is we isolate the x squared as much as we possibly can. So we add 3 to both sides, and we get x squared is equal to 3. Then to undo this 2 power, we will take the square root of both sides, and when we take the square root, we have to add a plus or minus. So that gives us x is equal to plus or minus square root of 3 as our additional 2 critical numbers. So now we draw the number line. So we have negative square root of 3 would come first, then 0, and then square root of 3. And we will plug this into our derivative. Now, keep in mind, you can plug it in, this in this case is g, you can plug it into any format of the derivative. So at one point we had the derivative was 8x cubed minus 24x. You could plug in numbers into that formulation, or you could plug it into the factored form. So either one is perfectly acceptable, you're just trying to find the signs. So for example, I could go over here and I could plug in, let's say, -10. So that would be way over here, way past the negative square root of 3. So we would have 8 times -10 to the third minus 24 times -10. So what you would do is you would go through the calculation of that, and all you are interested in, again, is it a positive or a negative? So you actually get quite a big negative number here, but again, the important thing is that it's a negative. So that negative goes on our number line. Now, between negative square root of 3 and 0, we could plug in, for example, -1. So we plug in -1, and again, we work through the computation. So in this case, we get a positive number. So that plus is going to go on our number line. And then just repeating this process, what you will do is you will plug in, for example, 1 into the derivative. And when you plug in 1, you're going to get 8 minus 24. So that gives you a negative. And then you might plug in, let's say, 10 into the derivative. And when you do that, you will get a positive. From there, we notate that the negative tells us that we are decreasing, positive, increasing, negative, decreasing, positive, increasing. So to summarize what our results are, what we have here is we have a minimum, relative minimum, at negative square root of 3 and also at square root of 3. Now, to find these values, what we need to do is we need to plug into the original function. So what I will do is I will take my original function of 2x to the 4th minus 12x squared plus 10 and plug in the negative square root of 3 to the 4th minus 12 times negative square root of 3 to the 2nd plus 10. And when you do that, you will get -8. So we have a -8 coordinate, and then our relative minimum with the square root of 3. If you plug in, you will also get -8. Now, we also note that we have a high point here, and that would be our max. So we would also have to say that we have a max at x is equal to 0, and then to find that corresponding y value, we go back to the function, the original